Jamak, welcoming you to another episode of the 3 Asset Challenge. As always, I will spin the giant wheel 3 times, and then have only 1 hour to build a game using all 3, and only those 3, randomly selected assets. Let's get started. They're slowing down, finally. Okay. We've got the Halloween music pack from Composer Squad. Alright, so we've got background music. That's a good start. Alright, here's our Halloween music pack. Let's take a listen. Okay, good choices here. I do see that there are loops available. We're going to want to use one of those so that we can play a constant loop in the background in our game. Okay, spinning again. Finally starting to slow down. Oh, right on the line. There we go. Okay, idyllic anime Japan. Okay, so now we have a setting for our game. Here we have the idyllic anime Japan. It looks nice. And what we're looking at here is the sample scene. Of course, each of these individual objects can be used to create our own scene, but today we'll just be using the sample scene. Alright, we're spinning. And we've got Heroic Fantasy Creatures Ultimate Collection. Alright, this is a bundle of 3 separate collections of creatures, so we will have a lot of choices. Let's take a quick look. Alright, let's take the first bundle. A lot of good things, a lot of dragons. Second bundle, Kraken, Phoenix. Third bundle, a lot of were creatures, more dragons. Spot check. 2. Nice. 3. 4. One more. I got a harpy too. Okay, I've started a Unity project. It's a 3D project, and of the 3 pipeline choices, I selected the Universal Render pipeline because we don't need the horsepower of the high definition render pipeline, and there's no reason to return to the built-in legacy render pipeline. I've installed the Halloween music pack, all 3 volumes of the Heroic Fantasy figures, and the idyllic anime Japanese village. Alright, let's take a look at that first. Oh look, pink! This asset was made for the built-in render pipeline by default, so I'm going to have to do some conversion. This pink is the color Unity uses to say that it can't render a surface. We should be able to fix that by converting the materials to URP. Let's find out. Looks pretty good. I am noticing a couple of oddities. See these flowers? They aren't cut right. They're all squares instead of a leaf shape. And these decals on the road stick out. If I remember, when we looked at the site, we didn't have that, and this asset does say it works with the Universal Render pipeline. Alright, so this is one of the materials. I'm betting we're only supposed to see these lines, but the whole thing is opaque. Let's switch to transparent. Not bad. And alpha looks fine. Let's turn the alpha clipping on, and good. Okay. Let me just do this a few more times. So we are ready. Let's see. And let's go back to the circle. It's a nice place to set up shop. Let's take a look at these creature packs. Okay, so they're organized. Let's grab some critters. Okay, let's take a look, see what this looks like so far. Good. These creatures come with their own animations, and their default demo animations are already set up, so that's what we're looking at now. All right. I think I know enough now to design our game. We have no coding assets, no character controllers, nothing that'll break up buildings and such. So let's simplify this. And okay, we have the wolf. We'll make the wolf the main character, make that our hero. All right, before we dig down deep, let's get organized. We have all these assets from the village. We don't want to confuse those. Let's grab those and put them under their own parent. Okay, make it so that those are untouchable. Makes it easier to select our characters. Good. Okay, if we scale up our Cyclops, 10 times seems a mite too big. Let's try 6. Yeah, that looks good. All right. 2 down. The third one, I think for a game like this, a simple game we can create in the time allotted, let's have the wolf run around doing pickups and getting points every time they pick them up. And let's use the Werespider as the pickups. Why not? It would be kind of fun to come up with a story where this wolf must collect all the Werespiders to fulfill a prophecy or a debt, because she loves them as her own. Who knows? But we'll do that. Say, gotta scale them down though. That looks good. All right. We're going to be creating our own assets shortly, so let's create a place for those. I always like to use my company name, Jamak, just a matter of code, with an underscore, which keeps it towards the top. And then underneath that, create a folder for each of the object types I'm creating. We're definitely going to need scenes and scripts. Let's see what else. Prefabs. Most likely we're going to create prefabs. All right, and that should do it for now. Okay, save to our new scene folder. Okay, let's start by creating the NevMesh. Unity's built-in navigation mesh will save us from a lot of coding. We'll install that from the Unity registry. It's under AI navigation. We're going to be using 2 kinds of AI today, actually. The first one is this one, a mechanism that makes characters seem to move on their own, make their own decisions. We'll only be using a very small part of that today. The other kind, of course, is the generative AI that has been in the news a lot this past year. And we're going to use that AI to generate some of our code. Okay, let's create a new empty game object. We'll call it navigation. Underneath that, we will put a NevMesh surface. And we will bake it. The blue everywhere shows where the character can walk. Now, this is pretty extensive, goes pretty far. Also includes the top of roofs, top of trees. We'll have to fix that later. We don't need the wolf walking up there. Keep in mind we're doing just broad strokes first. We'll fill in the details later. Okay, step 2 is setting up the wolf to be a NevMesh agent. Okay, we'll just take the defaults for now. Next step, let's create a script. The purpose of the script is to tell the wolf where to move on the NevMesh. We're going to start that by clicking on the screen with our mouse, and whenever we click on, the wolf will walk to that location. The method I'm going to use to do that is called raycasting. Imagine a ray being cast into the screen from where your mouse pointer is, casting it until it reaches something. Could be the pavement, could be a tree, could be a stop sign. Then once it reaches something, it reports that location to the NevMesh agent as its new destination. Okay, we're starting off with the usual template. We put code here that runs once before the game starts. And put code here to run once for every frame. And up here, of course, is where we declare our variables. We're going to get a handle to the NevMesh agent, and we're going to get a handle to the main camera. All right, NevMesh agent, perfect. So it's going to get the object that the script is attached to, in this case the wolf, look through its components and find the NevMesh agent and return a handle to it. Now get a pointer to the main camera. Now for the fun part. First we want to detect whenever the mouse is clicked, so that's going to require an if statement. If input get mouse button, there we go. And 0 refers to the primary mouse button, which for most people is the left mouse button. And then we want the wolf to move to the cursor point. Let's create that method. First we'll create a ray. Main camera, there we go. Screen point to ray. Input, mouse position. So it's going to take the position of the mouse click and then turn that screen point into an array. Unity, in fact, has a lot of these functions built in, which makes everything useful, which is why you want to use a game engine like this. Okay, and I'm going to do Boolean is hit, and we'll reach into the physics library. Get the raycast method. It'll return true if it hits something, and will return all of the information about that hit through hit info. So if a spot is hit, we will change the NevMesh agent's destination to the point that was hit from the mouse click and walk to that point on the ground. All right, let's save this and go back to Unity. Let's see how we're doing. Okay, we haven't done anything about the animation yet, so he's just sort of drifting around. We click on the screen and he moves. You see he's going through his base animation. So it's going to go through all sorts of odd poses. We'll fix that later. Broad strokes. Our first problem I notice is we can only go in here because the camera is not moving with him. So we can easily go right off the screen. Let's fix that next. Okay, we're going to need another empty game object. I'm going to call this one follow camera. So we're going to match the follow camera to, let me see here. Okay, there's the camera. It's pointing to the wolf, just because we happen to point it there. But we want this to move around, this camera to move around as the wolf moves around. We're not going to have it spin or anything. And keep this from being dizzying, or from being too complicated. We'll just have it move around matching this. So I'm going to create a follow camera, and then let's see, the wolf. We're going to take its location. We're going to paste that onto the follow camera so they're in the exact same spot. Okay. Get your main camera and the point that's representing the follow camera. Let's take the main camera, make it a child of the follow camera. So now as we move the follow camera around, the main camera will go with it. So I started out with the follow camera and the wolf being the exact same spot. So we just move the wolf and this follow camera spot together, and the main camera will come with it. All right. Need another code module. This will be follow camera. Okay. We're going to want to assign from the outside. That's why we need the serialized field. We're going to want to assign a transform. I'm going to call it target. That's good. We don't need anything in start, I don't believe. We're just going to need, for this object's transform, position to equal the target position. So in every frame, it's going to update this position for this to match the target. Save this, go back. Okay, we have a follow camera object, which has a transform and a position, which we just referenced. But first, we need to pull the follow camera script to it, and then set the target. And the target is going to be the fantasy wolf. So now this is reusable code, so we can use this for anything. If we decide the main character is going to be the Werespider, we just change that. It's going to follow the Werespider everywhere. Okay. Let's run that. There we go. It's very slow, but it's working. All right. I don't have the patience for something that slow. Let's go to Fantasy Wolf. Or what does 10 look like? That's a little better. It's going to be hard to tell until we actually can get the running animation working. Okay. Okay, I think it's time to fix that animation now. It looks a little silly scooting across the grass. When canine scoot, it's usually not a good thing. Okay, here's the animator for this object. So they each have pre-set up animations. All right. What this does is it comes in. Let's make the zoom. There we go. Entry here. Goes to idle breathe. And it goes to idle look around, to rest, resting, go back up, howl. And this is the sequence we've been seeing it go through. But we don't care about any of that. We care about walking. We care about running. I think we do care about the idle breathe. That's all we care about. All right, if we don't want them here, we want them on a subtree, a blend tree. Okay. Okay, idle breathe, good. Okay. So what this means is as this value here changes, it's going to blend from idle breathe to walk to run. Let's get this running. It's going. Idle. Start moving it up. Starts walking. To running. All right. Nice smooth way as well. This is going to make the animation look good. Plane trees are cool. All right. This is just the default settings. We're going to want to change these. We don't know what to change them yet. We're going to have to look at the animation and adjust accordingly. But right now I can tell you if he's moving at all, we want him to be walking. All right. So as soon as it comes off of 0, he's walking. Okay, we'll have to try to figure out the exactly where to transition into running. Okay. Parameters, we're going to want, let's change this to speed. That makes sense. Okay. All lowercase, that's important to remember. Okay, now let's go to our scripts. I think this is the last script we'll probably be writing myself. Then we're going to hit the AI to do the rest. Actually, don't need a new script. I think we can just piggyback off of this one. Okay, move cursor and then, okay, yep. Update animator. Generate that function. All right. Yep. So we're capturing the current velocity, but this is global velocity. We want local velocity. The nice thing is that Unity comes with something to do that. Inverse transform direction velocity. Yep. All right, now we have the local velocity of the wolf. You didn't expect physics today, did you? Well, this is gaming. And speed is going to be the local velocity z. That's the direction he's going to be moving in. All right. Now, when we get that speed off the wolf, we're going to need to know how to translate that into the speed. Because right now we have the speed, the velocity of the character moving in our game. We need to translate that to the animator so that it changes state at the right time. Okay, and we don't know what that is yet. I have not used these assets before, so we're going to write out the debug log, what the speed is once we get it. Okay, this, skip component. We want the animator. And within there, there's the set float that we created. A floating point variable called speed. This is a string, and if you were to capitalize it or anything else, it wouldn't work. It has to match exactly. So, is there anything more complex than just the word speed in lowercase? It's just copying and pasting it. Okay. Let's see what that looks like. What did I not do? Oh, I know. I created this blend tree and attached not much to it, so we gotta get rid of these guys. There we go. Now everything will go there. There we go. Much better. Look at that. Okay, you can't turn for crap, but we'll fix that. Let's look at the console. So yeah, he goes all the way up to 10, which makes sense because we set it at 10. That tracks. Okay. So running will go all the way up to 10. Let's try 5. It's not bad. So it waits until he's really picking up speed before it switches to run animation. Not bad. Alright, that turnaround is a little crazy. So unlock this. There we go. Angular speed. Let's go 1,000 on that. Still turning poorly. There we go. You notice there was animation for turns and all sorts of stuff, so we can make a very complex blend tree and really get the animation perfect, but not in the time we have today. Alright, looking good. Alright, now it's time to scatter Werespiders around the town and then pick them up. At that point, I think we're going to do the rest of the coding in AI. That should speed things up nicely. Alright, we are ready to create all the pickups. So what we want to do is spawn all of these Werespiders into a delightfully creepy number. Alright, we got ChatGPT, and we've got Act as Unity 3D Expert. That's my pre-prompt. How can I create and place 100 instances of a prefab at random locations around a NevMesh? Okay, first of all, create the prefab. We've almost done that. Create a NevMesh. We've done that. And then write a script. Let's create the prefab first. Okay, we're going to create a prefab of the wolf spider. And yes, we want an original prefab. I don't want to mess with the original one that was created. Alright. What I want to do is actually remove this from the scene. Now we have our prefab that I can add back into the scene. And I can make many of them. Let's turn the NevMesh off for the moment. There we go. So we're going to have them all over the place. Right. For right now, we're going to delete them all. Okay, let's get the script. Okay. First, we're going to want to create a new script with that name. There we go. New template. And now we're going to take the rest of the code. Select all, paste. Alright, let's see what this is doing. Okay, so all three of these are public. I think the intent for making them public here is so that we can access them in the user interface, but what's better than public is using serialized field to make our code safer, so they can only be accessed here or in the public interface, not everywhere. Okay, we're defaulting to 100 because that's what I told it. Area of 10 is the radius. We will start with that. And we want to give it the prefab to spawn, and that's the prefab we just created. Okay, it's going to go through 1 to 100 and call it spawn prefab, and spawn prefab, it creates a random point from this object's position. So this, whatever we attach this to, is going to be the center. In fact, let's save this. Center. Attach the spawner to it. And now we want our prefab right there. We're going to start with 100, 10 meters in radius. But we need this spot to be the center. Right here, it's way off. So let's do this. Let's look from above. Let's flatten it out. And I think right about there. Okay, back to the script. All right, the position, we just took care of that. We want a random point inside the sphere and multiply by the radius that was specified. What we want to do is take that random point on the NevMesh and then output the hit. All right, cool. Takes the information in. Those all areas. We might want to modify that later if we were building this into a real game. I should say a professional game. And they want to instantiate, which is how you create any prefabs in the scene. You call it instantiate. We want to create, where we want to create it, and this is the rotation, which using the identity is just saying keep the same rotation. I see one potential issue though. We want 100, right? And it only create one if it passes this test. It's only calling this 100 times. So let's say 10 of them do not pass this test. So we're actually going to end up with 90. And if we're counting points, or don't let the wolf get on to the next level until it collects all 100, then that's not going to work. But we will look at that later. And ChatGPT created exactly what I said it. But, well, I did say create 100, so maybe not. Anyway, we will tweak this later. Everything's saved. Let's go. Okay, there's 100 clones there. Okay, there they are. We can see the circle is very small. But it is centered around our center point. All right, let's try 60. In fact, to make this even easier to see, let's do 10,000. That is a lot. All right. That looks like the coverage we want. You can see how 10,000 has really slowed things down. All right, we have one problem. Let's turn the NevMesh back on. Or I should say the NevMesh visibility, because it's always on. The effect of it. All right, look. So we still have the treetops and the rooftops and everything else. And it's quite possible that some of these guys are going to appear. Yep, there's one right there. Places where the wolf can't get to it. So we need to fix that. There's several ways of doing this. I like the idea of having the NevMesh just on the pavement. And then that is where the pickups will go. We could create a second NevMesh, but for simplicity's sake, we'll just use the same one. All right, we're going to create a new layer and call it pavement. and we want nothing except for pavement. Okay, after a quick look, it looks like what I need to do is find all objects with the word sidewalk Yeah, it's nice. We filtered on the sidewalk. Select all of those. Change their layers to pavement. Alright. And then asphalt, which is our big circle. And lastly, street. Nice. Which is all the street except for the circle. So navigation is set to pavement. Now we bake this again. Haha, and there we go. So this is the NevMesh. Now if we run this now, two things will have changed. One, the wolf can only run all those places because we're reusing the same NevMesh instead of creating a second one. And two, all of the Werespiders should be accessible if I can find them. Oh, this one. Alright, so there's no contact yet. We just made them be placed, not interacted with. And to save time in our future tests, let me create more of these so we don't have to wander around for 5 minutes finding them. Alright, time for our next ChatGPT script. I have a player prefab and many pickup prefabs. I want the player to move around and pick up the pickups when touched. When they touch, the pickup should disappear and an on-screen counter should increment. I already have the pickups placed around the scene and the player can move around via user control. What else do I need to do? Alright, first we want to create colliders. That makes sense. So we can detect each other. And then we'll need the script. Alright, let's do this part first. Create a new script. Bring it up. Paste it in. Change this again. It's using the tag pickup. We can change that, but I think that's a good idea. And as soon as we collide, that this collides with pickup, then the other, I'm going to make the pickup disappear, increment the counter, and update the counter on the screen. Okay. Assign this script to our wolf. Let us create our text field. Okay. We're going to want to, I think the lower corner would be good. There we go. I think we want score. That's a good format to use. Yeah, see? There we go. Alright, we've not created the colliders yet, though. Use a box collider. Alright, it's flat. So this is the box that'll be the collision box. Yes, it would be more accurate if we had it shaped exactly to the wolf, but it'd also be computationally intensive. So we're just going to use a box. So the physics engine will just see a box. It won't care about the wolf and all that detail. We want to say it is a trigger. So we don't want them to bump off each other. We want them just to run some code. Alright, now we need to add a collider to the spider. In this case, directly out of the prefab. There we go. Mm-hmm. All right. Let's see what we got there. Nice one right there. And nothing. You know why? Because we missed a step. I don't think ChatGPT said this, which is why you shouldn't always blindly follow AI. But in order for the box colliders and everything to work, we need to make our objects rigid. Let's turn off gravity. We're not using it here anyway. And let's see. Same here. Same thing. Turn off gravity. And I forgot to turn on is trigger before. Okay. Oh. Sometimes you do need to follow AI, because I forgot another step that it did tell us about. Into the Werespider. Again, we've got to give it the tag. What did it say? Pickup. Create a new tag called pickup. And it needs to be spelled correctly. Alright. Pickup. Okay. See, what is it did? Is it most likely came in here, triggered, and because it was not tagged pickup, it just went on. So now it's tagged pickup. It should run the rest of the script. Boom. And I got a point. All right. As I suspected, we're not going to have time today to work in our kaiju Cyclops. But I'll save us something to do later. I think I'd also want to put a timer. You have both. One, you have to find 10 of these guys within 30 seconds while the town's being destroyed. So you have what they call in fiction writing a time lock and an option lock. Both. And I'm just having fun around, collecting up my little Werespiders. Alright, we only have one thing left to do. That's the third asset. That's background music. Oh, the music back. Alright. Like I said before, we're looking for loops. Okay, we got 2 loops. Let's try the first one. second one. Yeah, the first one sounds more like chase music. Alright, let's create an empty game object again. Call it music. Take the one we want, drag it onto it, and yep, it'll automatically create an audio source and assign that as the audio clip. Alright. Play on awake, yep, and loop forever. It's the least sophisticated way of doing it, but it works for today. Volume, I don't know, let's try it about there. Normally we'd have sound effects as well. We don't want one to drown out the other. Let's see what we got for our completed game. Alright, we did it. We created a complete game, scoring, objectives, and everything. That's it for today's 3-asset challenge. If you would like to see me continue this game, maybe with additional assets, to get the advanced stuff that we had talked about, especially the enemies and the timing and the destroying of buildings stuff, let me know in the comments below. Regardless of that, I'll be back in 2 weeks' time for the next 3-asset challenge. Thank you.